Hi, this is a supplement to the Executive Black Belt course, week 5, and the section entitled Indicator Variables, starting at slide 150 and ending at slide 168. And again, this is just really an introduction to this, but I want to show you how you can start to put in these mixed models. Up till now, what we've done is we've looked at a series of models, how to build a y equals b1 plus b2x plus b2 whatever model based on this. When we have a y that's a number and we have an x that is a number, x1, x2, x3, all of these are numbers. Well, what happens if one or more of these is a cat? What do we do then? How do we build that into our model of the y equals b0 plus b1x plus b2 x1 plus b2 x2 plus ... right? So we haven't yet considered that, and yet it's a pretty common case to have a y that's driven by a categorical x. For example, we certainly could have in our restaurant example, our y could be the wait time between when you order your meal and when you get it, and maybe one of the drivers, x1, is the cook. You know, which cook? Maybe I have 3 chefs, and they all work on different shifts and days, so I could go into that restaurant, and I don't know which chef I'm going to get when I order the lasagna, and so I might wait under some chefs. Under chef number 1, I might actually have to wait on average, say, 5 minutes longer than for chef number 2, and so forth. Okay? So what we might want to do is build one of these models such that we're making an adjustment each time. Okay, so that's the setting that we're going to go into. Now I want to do this in a couple of different parts. The outline that we're going to have is, number 1, we're going to simple 1 cat x for 1 y. Okay, so in this particular case, I want to do 1 y and 1 x, where x is a cat and y is a num. Okay, just to show you how this basically works and how what we really mean by an indicator variable. That'll take a little bit of time, but not too much, and then we'll do what I think is a pretty straightforward example to show how using indicator variables technique we can improve a regression. So improve with 2 x's, x1 and x2, where x2 is a cat, and we'll see how we can improve that. Number 3, I want to show you in Minitab, I want to show you Minitab's general regression area, and in this case this is going to allow us to go a little bit beyond the indicator variables. I just want to introduce you to this, okay, so that we can actually make full models with 1 cat, 1 num, and any number of cat things, but we're taking into account all the interactions between the two. All right, so I do want to show you that. Okay, so let's go into it. The first case is going to be 1 cat, 1 y, 1 cat x, 1 y. We're going to do the example that's actually in the book, which is job type by wait time, or wait time by job type, I should say. So in this case, we've got, ooh, there we go. I always do that. All right, there we go. In this case, I've got wait time, and I've got job type, right? And that's a cat, and that's a num. Now we already know how to handle this situation. So you might think that this is like I submit a job to IT, and the amount of time for the help desk, and this is the amount of time that I have to wait minutes before somebody contacts me. So that's what you could do it. If you don't like that, use the old restaurant. You're waiting for your meal, and there's 3 different types of cooks, or 3 different cooks that are in the back. Okay? And it depends on which order it goes to, and you don't know, but we're going to take some data. Okay, now we've already analyzed this in Excel stats, and if we're comfortable with that, maybe we ought to just go with the usual answer, which is, first of all, to see if it's, use our PGA wheel and to see if it's significant and all that. Well, the first thing that we know we ought to do is to maybe make a box plot or something like that. And when we do, we see that the means are a little bit different from each other. But the question becomes, are they significantly different? And for that, we could use this, or we could use an ANOVA. If you recall, we did ANOVA analysis on this in a previous section. Okay, so one of the things that you'll see pretty much immediately is that there are significant differences. So if you were doing this, if you were making an adjustment and you built a model, your model might be the following. Let me go back to here, and now that I see the picture, and we're going to assume for a moment that the differences are all significant. I believe that if we went to test by two categories, we'd show that they were. Here's T1 and T2. Yes, they're different. Here's, I'm sorry, that was T1 and T3. Here's T1 and T2. Yes, they're different. And here's T2 and T3. Yes, they're different. So they all are different. That's great. So far, we haven't done anything differently. Let's go up to the data, and if we look at the means, make that a little bit easier to read, we could look at it as follows. And this is actually a pretty simple model. What we might want to do is, if I were doing this, I might build a model that said, well, my y, my wait time, is equal to 115 if it's T1. If I submit job number T1, I'm just going to put a multiplier by T1 right there, and you'll see what happens in just a second. Or I might want to do, say, I wait on average 93 minutes if I submit a job type 2, or I'd wait 146 minutes if I submitted job type 3. Now, watch what I'm going to do. I'm going to form switches out of T1 and T2 and T3 such that whenever my process is in state T1, in other words, if I submit a job type T1, that makes T1 equal to 1, T2 equal to 0, and T3 equal to 0. So in other words, if I submit, I'll formulate a variable, or maybe 3 variables, T1, T2, T3. I'll call them indicator variables, and my definition is T1 is equal to 1 if job type equals T1, 0 otherwise. And likewise for the other two, such that, now note what's going to happen if I plug in, I'm just going to plug in the answers here now. If I plug in, let's suppose I submitted job type T1. My y would be y equals 115 times 1 plus 93 times 0 plus 146 times 0. These guys drop out, and I'm just left with 115. You see that? So my model predicts what I would normally predict. Now this is just sort of common sense, and using what we've done before. The real question is, how do I understand sort of how much maybe what's my R squared, right? I might want to know my R squared. So I'm going to show you how to do that, and then we'll move on to doing the more complex one, okay? So unfortunately or fortunately, there's an easy way to do this in Minitab. It's not trivial in Excel stats. There's no real way to create indicator variables easily, but there is in Minitab, and I'm going to show it to you. Okay, so let's port this over into Minitab. Okay, so I've got it into Minitab right now, and What I'm going to do is in Minitab, it has a nice little function that creates an indicator variable out of this one. So watch what I'm going to do here. I'm going to do calc, make indicator variables, and this is pretty slick. If I click on job type 1, look at what happens. Minitab knows, it can read it, and it separates into job type 1, job type 2, job type 3, and creates these 3 columns for me. Bam. There it is right there. And notice that T1 always gets a 1, 0, 0, T2 gets a 0, 1, 0, and T3 gets a 1, 0, 0. So it's a nice way to separate out all of your, if you have a categorical variable that has like 5, it'll separate it out into 5 variables, and so forth. Now it's simply a question of putting in the regression equation to see if what's significant, right? So let's put in the stats. This is just going to be very straightforward, I think. There's one little wrinkle that we're going to find, but it won't be too bad. So if we put in wait time, let's put in predictors 1, 2, and 3. Okay. I'm not going to worry about the graphs or anything like that for now. Let's just click okie dokie, click OK, and let's see what happens. Okay. So here it is right here. And it says regression analysis for job type 1, job type 2, job type 3. Now notice these are all indicator variables. An indicator variable simply is that switch. It's that 1 or 0. Let me go back to that for just a moment so you'll see it. Notice it's just a 1 or a 0. So you can think of it as a light switch. I either switch, what type of job I want, right? It's like a radio button. I click on one, the other 2 go off. I click on the next one, the other 2 go off, and so forth. All right, now let's take a look at that session window again. Okay, so now it says that it builds the model, and now this is very interesting. My wait time is equal to 92.9 plus 22 times job type 1 plus 53 times job type 2. And you might be wondering, wait a second, what happened? What about job type 3? It's gone. I don't have my adjustment that I wanted to make. Darn it, what happened to that? Well, here's what happened. Job type 3 is absorbed into the constant, and to prove it, let's go through and let's see if we plug in our numbers, if we get what we got before. So let's try it. All right, delete this. If I plug in, let's suppose I have job type, my JT equals type 1. Then my model would be wait time is equal to 92.9. I'm going to call that 90. I'll call it 92.9. That's fine. 92.9 plus 22.5 times JT1, right, which is 1, plus 53.1 times JT2. Which is 0 in this case, right? It's the indicator. The switch would be on 0, 53.1 times 0. This drops out, and I just get this is equal to 92.9 plus 22.5, and voila, that's equal to, let's see if I can do the math in my head. 92 plus 22 is, I could do it, is 112, plus 2 is 114, plus 1.4. So it's 115.4. Okay, I rounded a little bit before, but that's what we got for our answer before. Okay, so it's exactly the same. Darn Minitab for putting it into a different formula, but there we go. It's basically the same. Let's see what happens if we have JT equals T2. Well, our wait time is equal to 92.9 plus 0 plus 53.1. Okay, and that is equal to 146. That I could have done in my head. That I could have done in my head. All right, and finally, if JT equals 3, equals T3, we'll get our wait time equal to 92.9 plus 0 plus 0, which is equal to 92.9 if it's job type 3. Okay, now if we go back to our original Excel stats, our one num, right here, that's exactly what we got. For job type 1, we got 115. We put one more significant digit so we'll see it's right. 115.4. Type 3 was 92. I don't know why it does T1, T2, 3, T2, but anyway, it does. T3 was 92.9 and T2 was 146.0. That's exactly what we got out of our model in Minitab. Right? Okay, 115 for J1, 146 for for type 2, 93 for type 3. That's it. Now the other thing that we can get here, of course, is we can get our R squared. So we know that just the type of job accounts for 35% in the variation of wait time, and that it's significant. See, these are significant. We could have done this by doing an ANOVA test or anything like that. Here's another way to tell whether it's a significant factor or not. Okay, so obviously we could use it for predictions and all that kind of stuff too. It's all well and good. Okay, so that's basically it, and I want to show you that now I'm going to do this. I'm going to do the regression again, and if I go to Stat, Regression, Regression, and if I go into Options, I can remove the constant term that's called the intercept. If I remove the intercept, we'll get an equation that's a little bit easier to read, but then we'll lose the ability to look at our R squared. That's another one of the reasons why statisticians like to keep the constant in. If I take the constant out, there it came back, job type 2, job type 3. There it came back in. Now that may be kind of strange to you as to why this is happening, but let me kind of explain why this is happening, and it's related to something called degrees of freedom, which we will see, which we actually see right here. In terms of it's called DF, and it simply means how it's related to whenever I build a model, whatever that model is. Let me erase it all. In this case, I've got a y equals, let me just call it alpha 1 times T1 plus alpha 2 times T2 plus alpha 3 times T3, right? In this case, it's the number of alphas that I need to estimate that's going to tell me my total degrees of freedom. In this case, it says that there are 3. One for this alpha, one for this one for this. When we wrote the equation before, it was like this. I'm just going to write it slightly differently, but you'll see it's really the same. B0 plus B1 times T1 plus B2 times T2. It's really the same. We still have 3 that are going here, but they'll just be separated into a different place. Okay? So when I hit the, I'm going to try this again. Now I'm going to hit the Control E. Yay, it worked. If I fit the intercept again, let's look at this analysis of variance table. And now it says, well, wait a second, my source of regression is 2 degrees of freedom. That's right, and that's because we included the constant, and the constant takes away a degree of freedom from us. See that? It's taking away 1, and now our regression is taking away 2 instead of 3. All right? So that's where it's all going. And now you can think about it also tactically as why does this really only have 2 degrees of freedom? Why wouldn't it have 3? Think about it like this. Let's take a look at our thing right here. If I can really only specify 2 of these, and when I specify 2 of these, I always know what the third one is. So for example, if I tell you JT1 or JT1 is 1, JT2 is 0, we know automatically that JT3 is equal to 0. Likewise, if we tell you that if I tell you that JT1 is 0, JT2 is 1, I automatically know JT3 is 0. And finally, if I tell you JT1 is 0, JT2 is 0, I automatically know that JT3 is equal to 1. So I only really can specify 2 of those. I can't specify 3. And so mathematics, there's some little tricks that happen in there. This is all covered in the book, and it's all very straightforward. This is really just the example starting at on slide 154. Okay, so now we're going to cover a much more interesting situation. Hopefully that was reasonably interesting. You can get the equation out. That's great. But let's cover a more interesting situation, and that is what happens if I have a model that has one num and one cat. How do I combine those into a model? For that, we're going to do the example that is in the book, starting on 161. All right, and that's with forms and processing time. So if we take a look at that, what we have is we're looking at PT, processing time, which is a number, and originally we tried to describe it as, well, maybe the number of fields could tell me what my processing time would be, and that was a number, right? So we originally did that, and that's a linear regression, where this is fields and this is PT, and maybe it looks something like this. I think this was one that had some sparse data, but it was not that great of a regression. I wonder if we can use the type of form, by knowing the type of form, if that would help us fit a better regression. Okay, we're going to do this in Minitab first, because Minitab can do this dummy variables regression. And so the first thought is to simply say, okay, well, if we take form type in there, maybe what we simply do is we make an adjustment to the mean each time we know it's a different form type. So, for example, if it's form type B, use this curve. If it's form type A, use this curve. Make an adjustment that's like that. Now, people might say, hey, we're looking at parallel lines here, and that's fine, but you can think of it as just saying, I want to make a mean adjustment based on whether it's form type A or form type B. That's not an unreasonable thing to do. Okay, we still have this overall model that says, here's what the slope is based on the number of fields, and the form type A and B and C or whatever. We'll just make an adjustment based on the mean. Okay, what that amounts to is adding a bunch of dummy variables into our model that are going to be 1-0 switches that either add a constant or subtract a constant or something like that when they're on. Okay, so let's take a look and see what that looks like in Minitab. Okay, so here we are in Minitab, and the first thing I want to do is I want to make a graph of this. So if I made a graph of the scatter plot of fields versus processing time versus fields, let's do this simple thing. I'll just do it with regression, processing time and fields. There we go, and we got this, if you recall that, and we could fit a regression line to that. In fact, this is a regression line, and we found it wasn't the greatest. Okay. We could also see whether or not the form type was significant. So for that, maybe we do box plots with groups of processing time by form type. And here, just looking at one variable at a time. And it certainly looks like there may be some UFO action here, right? So it looks like maybe A, C, and E are all kind of one value, and maybe B and D are a different value. But there may be differences between these on average. So we could back that up by doing an ANOVA test Let's just go ahead and do that. One-way ANOVA, response is processing time, factor is form type, and there we have it. Yes, the P is low, so there's definitely a difference here, and so we'd like to add that into our regression model. So let's go ahead and add that into our regression model, and just kind of show you what it is. So what we're going to do is we're going to make an adjustment for each regression by just adding a constant for whatever form type we have. In Minitab, the easiest way to do that is to make indicator variables, form type. In this case, you'll see there's 5 forms, A through E. And there they are. And what we're going to do is now put this along with fields into our regression. Hit the F3, clear it all out. Processing time versus fields, as well as all of these guys. Now, you know what's going to happen. What's going to happen, oh, you know what, I'm going to just put them all in there separately by double-clicking each one. You know what's going to happen. Form E is going to be dropped out of the model, and this is detailed in the book as well, or in the binder as well. Form E is going to be dropped out of the regression, but you know it's really just hiding in the constant, hiding in that intercept. So let's go ahead and hit the OK. And you know, we can remove the things that are not significant, like we might want to remove form type A. But if we just wanted to leave them all in for a moment, here's what our model would be. You can see it's minus 9 plus 3.07 for fields, plus 7.09 based on whether it's form type A, 24 based on form type B, C, D, and we don't need to make the adjustment for E. All the E's will, E will just be A, B, C, D off. Okay? Alternative, and we see that we really did improve that regression. We went from like 37%. Well, let's see. I just want to remind myself what this was when we just looked at fields. So forgive me for just a moment. I'm just going to take this out. Yeah, we had a 50% regression when we just looked at fields. So by adding in form types A, come on, Mark. By adding in form types A, B, C, D, E, we improved that regression to 65%. So we made it significantly better. Okay. So let's go ahead and do some, before I do, I'm going to show you if I take out the intercept, you'll see E come back in there. There it is right there. Notice it came back in, and you also notice it became exactly that intercept. We had that minus 9.23 as a constant. Now it shows up as the coefficient in front of E. Let's write it out, and but now we don't have the R squared. So I'm going to go back to what we had before, fit the intercept. There we go. And let me just write out what we would have. Okay, so here is our processing time, PT. Let's suppose we had form type A, and it was 18 fields. No, let's say 20 fields. A is at 20 fields. What would we predict from our model? Well, we would have PT, let's just do it underneath here, PT is equal to minus 9.23, that's just a constant, plus 3.07, why'd I put a 9 there? Not sure, but I did. Strange. 3.07 times 20 plus 7.39 times 1, right, because it's form type A, plus, just to be explicit here, 24.1 times 0 plus 16.6 times 0 plus 14.1 times 0. All of these guys drop out, and I'm just left with it's equal to minus 9.23 plus I guess that's 60.14. Is that right? I believe so. All right, 6.14. No, didn't quite get that right. Okay, 6.14 times 10, so that's 61.4, plus 7.39. Okay, and that's our answer. I'm going to use my calculator here, my calculator. So 61.4 plus 7.39 minus 9.23, and that's equal to 60. No, that can't be right. Typed in wrong. So 61.4 plus 7.39 minus 9.23. 59.56 equals 59.56. And so that's my answer with this. When I plug in form type A and 20 fields, I get that. So the model spits out the right thing. Now it is complex. If we want to use the prediction in Minitab, we have to remember sort of the order that it all went in. So again, that would be stat, regression. I believe it's in results. No, it's in options. Yeah, there it is. Prediction intervals for the following. I want 20 forms, and I want, well, I think it was 1, and then 0, 0, 0. I think that's right. Ooh. Am I missing one? Let's see, 20, A, B, C, D. I thought I had that. Oh, I've got to put the last one in, even though it's, there we go. There it is, right there. It says, here's my new observation. So it's tricky because E is in there as a ghost, and it says that, yep, there's my fit, 59.56. I guess I was off by 0.01. And here's my confidence interval, my prediction interval that I would get from that. Okay? So that's basically how to do it. And just to look back up here, we have 5 degrees of freedom in our regression, and that means that we're fitting 5 constants, right? We have one for fields, one for form type, one for form type B, one for form type C, one for form type D. Okay? That's about it. And if you get that far, bully for you, that's great, and you should be good to go on, and you can see how you can fit and build models on this. You can see also that categorical variables, if you use many, many categories, this can be very hairy very quickly. So just keep that in mind, that there's a lot of things to estimate when you have to say there's many different categories. All right? So let me just show you one last thing before we close this up. And this is really sort of extra, and it's moving into where we're going in very soon in DOE. But what if, let's ask the question, I'll go back to the blackboard here. What if what we just did was we fit the following. We fit the y to the x, but we made different adjustments, different constant adjustments based on the form type, whether it was A, B, or C. I'll just leave it at A, B, and C, right? And it was a constant adjustment. But what if instead there was an interaction between the slope here, which line we got, which line we fit, and the type of form? Like, for example, one form A, might be much steeper slope than form B. Maybe that's for A and that's for B. And maybe C was even the other way. I doubt it would be, but maybe it was the other way. We might want to, in a case like this, here's our X and here's our Y, we might want to instead simply fit 3 separate lines. And so the question becomes, when do we want it to fit 3 separate lines versus just one? And it comes in something called an interaction term. Now again, if we're just in the adjustment mode and we feel that it's reasonable, we could go ahead and do that. Just make that adjustment. If we want to see if there's an interaction, we could also do that and see if that could improve our regression even more. Now the interesting thing is we can do this by looking at at the same example. And if we go to, what I'm going to do is let me go into Excel stats first and show you that Excel stats actually has a facility to do this. If you're doing this in Excel stats, it's called 2num 1cat. So if you do 2num and 1cat, we're going to select the right ones here. Here's a num, here's a num, and there's my cat right there. Okay, so I've got form type. And what I can do is I can look at fitting different slopes for each of these. And it looks like, for example, that form types B and form types B and E might get the same, might be just easy to adjust. And form types, say, D and C might be just easy to adjust. And B might be separate. We might have 3 separate categories for this. So instead of making an adjustment like this, which was kind of what we just did, add a constant for each one, which changes the slope. Again, it's not a terrible assumption. We might instead want to fit separate lines for each of these. Now, thinking about this for just a moment, let me show the equations. If I keep the same slopes, watch what happens when I click the equations. I really just have the same slope for each one. You see it's 3.07 times fields, 3.07 times fields, 3.07 times fields, 3.07 times fields. That's just what we got before. It's exactly the same. However, if I allow for different slopes, I have different slopes in there. So notice that I'm fitting actually more parameters, and it takes me more. We're going to find out it uses up more degrees of freedom to do this. What that amounts to is we're testing what's called an interaction. In Excel stats, they actually give it right here. The effect of, and it says right here, the hypothesis test is that the null is that the slopes do not depend on the form type versus the alternative, the slopes do depend on the form type. And the p-value here is low, so we'd say, yes, they do depend on the form type. So we might want to fit them separately in this case. Okay? So again, it's not like you're doing something that's not legal if you don't fit them, but you might have some advantage to fitting them separately. Let me show you how to do that in Minitab. Minitab is actually pretty cool because you don't have to create indicator variables for it. Although I happen to like indicator variables a lot, you don't actually have to do it. You can just use the general regression. Let me show you how that works. If I put in as my response processing time and my model as fields and form type, and then I have to say, here's what my category predictor is. It's fields. Nope, I'm sorry, I got that wrong. It's form type. What Minitab is going to do is it's going to create a model that's based on everything that's in there. It's going to calculate out all of them separately. And there it is right there. You'll see that, and this is a lot longer. Where are we? Okay. So here it gives the overall, which is what we had before. Oh no, here it is right here. Here's a general regression analysis. It says for form type A, here's my fit. For form type B, here's my fit. For form type C, here's my fit. Form type D, here's my fit. For form type E, here's my fit. And it's making them basically all the same without doing the adjustments. And you'll see that there's 5 degrees of freedom for that. 1 is in fields and 4 are in form type. R squared is 65.5 as it was before. Okay, so far nothing different than what we did with the indicator variables. So you can do it all at once without having to do it. This is new in Minitab. Okay, now however, this just keeps them all separate. However, if I put in an interaction between the two, and I'm going to do that now, fields times a form type, which is just the way that you indicate an interaction, kind of by form type. We'll look at them all separately, and hit the OK button. It actually does it all separately, and it's going to be asking for different form types, fitting a different equation for each one. And you'll see now it does. It fits different slopes for A, B, C, D, and E. And you can see that some of them are more similar than others. Like these two, for example, C and D are very close to each other, whereas some of the others differ. E and B are pretty close to each other. But it fits them all separately. What do we lose to do that? Well, we lost some degrees of freedom now. You see that there's 9 there. 1 is taken up by fields, 1 is taken up by form, and 4 are taken up by the interaction between fields and form. However, we do see that that interaction is a significant one, which is kind of interesting. All right, so we're just touching the tip of the iceberg with all of this. And by the way, that 0.016896, you will probably, if you had an eagle eye, you would have seen that it's exactly the same as that. See, that's at 0.0169. And then once we take that into account, then we can look at the intercepts do not depend on form type versus they do, and that actually turns out borderline significant, 0.1162. That's what this is right here in Minitab. See that right there? Yeah. So in any event, without getting too much deeper into this, we're going to cover some of this in DOE in a later lecture. But just to show you that we're starting to get to more complex models. But the key thing to remember is just doing the intuitive thing is not unreasonable. That is, if you have a categorical variable and you want to build a model and fold it in with a regression type of analysis, you do one of two things. You'd either fit a different line for each category type, or you'd make a simple adjustment based on the mean by each category to that line by just essentially effectively adjusting the constant each time. Okay, so just a quick recap on this. What did we cover? Well, we really covered three different things. First of all, we looked at one cat versus the x, and then we looked at what would happen if we had more than one predictors that were going to give us our y. And at the end, we looked at Minitab's general regression. Okay, so hopefully that was helpful. If you want to know more and you want help on this, don't hesitate to contact me at mzabel@straightlineps.com. Okay? All right. See you on down the road.